This question is one we did yesterday, but I'll remind you how this worked. I'll just go through the steps very quickly this time. We didn't finish it. I know we haven't drawn the graph yet and actually given that part of the question any time. So, but I'm going to remind you of the first part. We decided we needed to find where the two functions intersected, right? That was part of the question. What's the point where the two functions intersect? I know we have the answers already, but I'm just going to quickly go through that again so that it's on the recording and you can use that as an alternative to the whiteboard. So what we did is we set the two things equal to each other. I'm going to go through it more quickly this time. We set the two things equal to each other. Right, that's where you can find out where two lines intersect if you have the equations of the lines. We cross multiplied. So just using FOIL, we'd have x to the power of 4. It worked out to be plus 5x. If everybody remembers, 5x squared, that is. There's a 1x squared and a 4x squared, and then plus 4 equals 10. Then we brought the 10 over. So we get minus 6 equals 0. And then we said we could let, I think we use y, we'll use p this time, doesn't really matter. Let p equal x squared. So we turn this into p squared plus 5p minus 6 equals 0. All right. And then we said, okay, no, it looks more quadratic. That means we can do this. P minus 1, p plus 6, all right, equals 0. Then we put back our squareds in there. So this became x squared minus 1 and x squared plus 6 equals 0. We agreed that if we use a zero product law, then x squared minus 1 equals 0 meant that x was equal to plus and minus 1, the square root of 1. This had no solution, right? There was nothing that we could make x, there's no value of x that would make that bracket become 0. So these two solutions meant that we could now plug that back into one of the original equations, and we chose to go with x squared plus 1. So if we did that, we would have that y is equal to minus 1 squared plus 1, which was equal to 2. And if we did it with positive 1, you got the same result. 1 squared plus 1 was still equal to 2. So it meant that the 2 points of intersection, the POIs as I call them, were, the coordinates, were minus 1, 2, and also, I don't really want to use a joining thing. And the other intersection point, let me erase this here. The other intersection point was 1, 2. All right, so those are the 2 points where the graph intersected. Now, part of the question was to actually draw the graph, which we haven't done yet. So I'm actually going to copy this copy this thing over to another page so that we can talk about what it looks like when we draw it. Right? And this is just a rough diagram. I'm not expecting, it says, well, I mean, if I give you a grid, then you could do a better job. In fact, tell you what, let's put a little grid on there then. All right, a quick grid on there. I put a Cartesian grid on there. Right? And excuse me, one of the functions is x squared plus 1. What does x squared plus 1 look like? Well, we know it's just a quadratic function that has, in fact, it's like the x squared line that has been shifted up by 1. So if I put the vertex here, I'll use a different color actually. If I put the vertex here, I can use a step pattern across 1, up 1, across 1, up 1, across 1, up 3, 1, 2, 3, across 1, up 3. Hopefully you guys have heard about the step pattern, something you've learned before in math. So there's my rough sketch of the function, right? It goes up forever. It's not like it finishes at the points that I put on there. The other function is 10 over x squared plus 4. Now, you're probably wondering, what does that look like? Well, we've done questions like that before. Maybe you don't remember, but we have done questions like that before. And one of the things you need to remember is that this function, right, this function that I'm pointing to right here, this function has a continuous domain. It has no asymptotes. Does anybody remember why it has no asymptotes? We talked about this, I think, yesterday, right? Why does it have no asymptotes? Well, let me take that back. No vertical asymptote. I should rephrase that because it does have a horizontal asymptote. Does anybody know why it doesn't? Because you can't solve that. When you say you can't solve it, I need to be more specific, right? What is it that caused you to have a vertical asymptote, right? What part of this rational function leads to the vertical asymptotes, right? I want to sort of drill down on that a bit here. Okay, so I see a hand going up. That looks like Jeremy. Something equals zero. What's the something? Go ahead, Jeremy. What do you want to tell us? Yeah, yeah. So it's the denominator that you're trying to get to become zero for you to have a vertical asymptote. This denominator cannot give you zero. If you take x squared plus 4 and set it equal to zero, there is no solution. None. No solution. Right? There's no way to make this. You can't solve this. There's no value of x that's going to make that happen. So the answer to the question I was asking is, look at your denominator. What can make that denominator become zero? And in this case, there is nothing that can make it become zero. So that means that has a continuous domain. There is no interruption. There is nowhere the function doesn't exist along the x-axis. That's not the same thing about the range, though. The range is limited. So it goes forever to the left, forever to the right, but it does have a horizontal asymptote. What would be the horizontal asymptote of this function? And tell me why you think that horizontal asymptote is what you say it is. What's the horizontal asymptote? Anybody? Okay, Noah says it's the y equals 0 line. And Jeremy, you think what? Are you going to agree with that or you have a different answer? Okay. Can you tell me why? Can anybody tell me why Noah and Jeremiah, they're both right, by the way. Can anybody tell me why it is that they're both right? Okay, Jeremy, go ahead. Okay, we'll go along with that. That's absolutely true. So there is an asymptote, which I'm going to put in. Let me just put that asymptote in as a dotted line. I like to put my asymptotes in so that it always reminds me that there is, in fact, an asymptote. I'll put it in blue. We'll use blue for this one. All right. Here's my horizontal asymptote. And what does the actual function look like is the next question. Do we know where the y-intercept is? I'll tell you right now, there's no x-intercept. Right? It's hard. It's going to be asymptotic to the x-axis. No, I do know, and I have said to you that you can cross over horizontal asymptote. This one doesn't though. Does this have a y-intercept though? Does anybody know what the y-intercept is for this function? Come on, folks. Let us. I can't have Jeremy and Noah being the only ones who are going to give us answers in the group. All right, so Noah's given us an answer already, but is anybody else? Joel, okay, so now everybody's saying it's 5 over 2, which is the same thing as Joel and Noah when you reduce it down. So it's 2.5. So I'm going to say the y-intercept is right somewhere around, I use a different color. Let's use green. So it's about here. And what does it look like? It has to go down towards that asymptote. So it actually looks something like this. And I also remember that the two functions intersected at 1, 2. So minus 1, 2, and plus 1, 2. So I know I have to go through these 2 points right here. So I'm going to do this. All right, so that's not a very symmetrical drawing, but you get the idea, or hopefully get the idea from that. So the question is asking us to shade the area where one function is less than the other function. So the only place that that is happening, I'm going to shade that in with some dotted lines right now, is right about inside here. That's where that is happening. All right. All right. So you're above the quadratic function, but below the rational function. So inside that little purple area that I just shaded in is where one, that is this function, is less than this function. Okay, that's where that magic is happening. So if you ever had to do that on a diagram, that's what I'd expect you to show. between those 2 points, or in that little space right there is where the one is less than the other. Okay, so that is the end of that question. Started yesterday and we finished it today. Let's get to this question. Did anybody look at this question and figure it out for themselves? I'm hoping some of you at least tried it and might have had an idea of what to do. We know that a discontinuity of x equals minus 3, which is a vertical asymptote, would suggest that, let me go back to black actually, would suggest that the denominator of this function is going to be x plus 3. All right, can we all agree on that, first of all? Does that make sense? Right, we've seen vertical asymptotes before, and if this x equals minus 3 is a vertical asymptote, then I would suggest that x plus 3 probably is the denominator of the function that we're trying to find. Does that make sense? I need to make sure everybody is clicking with that first before I go any further. Yes or no? Okay, all right, good. I'm getting some reaction to that. Yeah, sorry, I thought it was a whole. Well, it says a vertical asymptote, though, right? It does say that it's a vertical asymptote. It says where a vertical asymptote exists. So we have to treat it as a vertical asymptote, which means x plus 3 is a good denominator for us to start with, right? So let's say that, okay, so it says it's a rational function, g of x over h of x. We may have an h of x already with this x plus 3, so we still don't know what the g of x is, right? We still don't know what the g of x is yet. That's a part that we still have to figure out. But the other piece of information that's interesting is that there's an oblique asymptote at y equals 2x minus 1. Okay, so an oblique asymptote usually is the quotient when it's in quotient form. So I'm going to make a suggestion here. I'm going to say, I'm not going to call this g of x anymore. I'm going to call this some other function here. Let's take away that g of x. And let's say maybe call it t of x for now. And then I'm going to put in the front of that 2x minus 1, Mr. Kamak. 2x minus 1 plus this t of x over x plus 3. If this 2x minus 1 is an oblique asymptote, then this is what quotient form would look like. It would be the quotient, because that's what the oblique asymptote would be, the 2x minus 1, plus some other remainder over x plus 3. So that would kind of fit with what we are expecting. Let me make sure that everybody is on board with what I just said. Let me remove that circle. Right? Does a 2x minus 1 make sense plus the 2, let's just call it tx for now, over x plus 3? Does that part, at least, that first part of this, sound about right? When we're looking at getting oblique asymptotes, remember, we took the divisor and divided it into the dividend, and what we got as a quotient, we put that on the side and said that the whole function could be expressed as a quotient plus the remainder over the denominator. Remember that? Does that sort of sound right? I just need to get some reaction on that before I go any further, because if that doesn't make sense, then we have to go back a bit. Okay, so I'm getting some reaction to that. Perfect. Okay. Now, here's the other piece of information. This is how wonderful math is. As you get more information, you find a place to fit that into what you already have based on the logic involved in math, and then see if you can build out the entire answer. So the other piece of information is that one of its two zeros is x equals minus a half. We have to find the other zero, but then we have at least one zero. So I'm thinking if it's a zero, doesn't that mean that plugging in minus a half into what we think the function, here's a function so far that we think it is. Let me just just going to circle it with my mouse here, right? We think so far the function is going to look something like this. If I plug minus a half into this, shouldn't that give us what shouldn't that be equal to 0? Right? Because it's a 0. A 0 means you plug that value of x into it, you get 0. That's what a 0 is. So I'm going to assume that if I plug 2 times minus a half minus 1 plus some t of x, and I don't know what t of x is yet, but we're trying to figure it out, over minus a half plus 3, that should be equal to 0, right? And that might give us what the t of x is on top, is what I'm saying, right? What's that function on top going to be? So let's see if we can solve. This is a plus. That's not a t, folks. That's a plus. Let's see if we can solve what we've got here so far. All right, let's see if we can solve what we have here so far. So 0 is equal to 2 times minus a half is minus 1. So that's 1 minus 1. And then plus some function t of x. We're not sure what that is yet. T of x over a half, sorry, minus a half plus 3, which is actually 2.5. All right. And then let's change everything into a mixed fraction, not a mixed fraction, a mixed fraction, into an improper fraction, and simplify the left side or the right side. So this is minus 2 plus some function, we don't know what that is yet, over, I'm going to call this 5 over 2. Okay? And if I'm dividing by 5 over 2, it's the same thing as multiplying by its reciprocal. So I'm going to keep going here. So 0 is equal to minus 2 plus this t of x function multiplied by 2 over 5. All right? And it looks like we're going to be able to solve this and get an actual t of x function. So let's keep going. I'm going to put the 2 on the right. So 2, positive 2 that is going to be this t of x function times 2 over 5. And now we have to take this and flip it again to multiply the two sides by the reciprocal of 5 over 2. So it means that 2 times 5 over 2, and I'm flipping it again, just so you know, because if I'm multiplying this side by 5 over 2, and I'm multiplying this side by 5 over 2 is really what I'm doing. Okay, multiplying both sides by the same thing. And the reason I chose 5 over 2 is because multiplying this side by 5 over 2 gives me 1, so it really just leaves it with t of x. So guess what? T of x is equal to 5. Wow. I think we just nailed what t of x is. T of x is just a constant. It's just 5. So here's what we have then, folks. This looks like we have part of this thing figured out. 2x minus 1 plus 5 over x plus 3. I'm going to write that down. So far, our function that we're working with here is 2x minus 1 plus positive 5 over x plus 3. This would seem to be the thing that would give us a vertical asymptote at x equals minus 3, very clearly, right? And also, it would give us this oblique asymptote at 2x minus 1, right? Because 2x minus 1 plus this thing over x plus 3 gives us this thing here. And we figured out that that was 5 because we had one of the zeros, and that 0 allows us to do this. Okay, so we have what looks like the beginning of the function. But now it says find the other 0 and sketch the graph. Use set now to verify your solution. Okay, how am I going to find the other 0, folks? Come on, turn that back over to you now. What other value of x is going to make this thing equal to 0? What do you think would be a good way for us to do that, to solve that? Any ideas as to how I might be able to solve that? There's another value of x that makes this equal to 0. Come on, folks, I need your help now. I'm not going to just spoon feed everything to you. All right, this is my function. I call it f of x. And Jeremiah has an idea. Go ahead, Jeremiah. Mm-hmm. 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 Hmm. Okay. All right. Um, does Jeremiah's idea sort of sound about right to the rest of the class? Because I want to be sure that everybody else is on board with that. Does that make sense to everybody else? Let's try it. Okay. Okay. So Noah's at least willing to give it a try, and Emily says yes. All right. Where's everybody else on this? Are we all following along? Are we all paying attention here? Are we all, do I have to start calling out some names? You know, I do that, right? And I really do take note of the people who aren't responding. Archana, let's start with Archana. Archana, are you there with us? You're suggesting the same thing. Good, Harish. Okay, good. So I'm going to go ahead and take your advice on that one. Right? I'm going to take, there's another way we could do this, but I'm going to take your advice on this. So you're that meeting Jeremy, by the way. Take his advice, and I'm going to go ahead and put why don't we do it this way? Why don't we bring the 2x minus 1 to the left side, right? So we're going to end up with 1 minus 2x being equal to 5 over x plus 3, right? I mean, all I've done is I've just taken the part that's not a fraction and put it on the left-hand side. And why am I doing that? Because we can now use that strategy that we learned in this rational functions unit for solving a rational functions equation, which is what? What am I supposed to do now? Cross multiply. Thank you very much. So let's try that. Put that over 1. So let's see now. That's going to mean I'm going to take x plus 3 and multiply it by 1 minus 2x and set that equal to 5. Unnecessary. No, it's adamant that he doesn't like me putting it over 1. All right, well, don't, when you don't have to do it when you're doing it. But at any rate, so let's cross multiply now. So that would be x times 1, which is x. X times minus 2x is minus 2x squared. 3 times 1 is plus 3. And then minus 6x equals 5. Okay? What do we do now? Right? Go on, folks. Yes, Jeremy, go ahead. Mm-hmm. Okay. Okay, let's try that. Let's try that. So I think what I hear is bring that 5 over. So minus 2x squared. And I'm going to put my like terms together, which would give me minus 5x. Excuse me. I'm going to have 3 and then 3 and then minus 5. So that would be minus 2 equals 0. Okay. So it looks like everything is negative here. All right. So minus 2x squared. The minus 6x and the x gives me minus 5x. The 3 and the minus 5 gives me minus 2. Now, here's my word of advice to you. Whenever I have a negative lead coefficient on a quadratic, and the other side is already equal to 0, by the way, what I do is I multiply through everything on both sides by minus 1. So everything changes sign. So instead of it being minus 2x squared minus 5x minus 2, it becomes, so what I'm really doing is multiplying this side by minus, or divide, let's say dividing by minus 1, because it's the same effect, right? Whether I multiply by minus 1 or divide by minus 1, I get the same result. Dividing by minus 1 makes this become positive 2x squared plus 5x plus 2. The other side of this is still 0, because 0 divided by minus 1 is the same 0. Right? So that doesn't change that at all. So yes, because we're looking at a 2 in front of the x squared, it's time to bring out the old magic x. So let's see if we can make this work. The top becomes 4, the bottom becomes 5. Right, that's a 2 times a 2, and then 5 is down here. I'm looking for two numbers that multiply to give me the top and add up to give me the bottom, and that's quite simply 4 and 1. And I'm going to divide both of these by the lead coefficient of 2. And then I'm going to reduce this down to 2 over 1. All right, if I cancel that down, and that's still 1 over 2. So here come my factors. So I'm going to get x plus 2, and I'm going to get 2x plus 1. Those are my factors. What is this down? Oh, I already have the graph down here. Well, I don't want you to see the graph yet, so I'm going to hide that for now. Actually, that doesn't help. All right, you know what? Let's just do this. Let's go back up. All right. Ignore the graph for now, folks. Pretend like you don't see the graph yet. But it looks like we have two zeros. X equals minus 2 and x equals minus a half. Well, guess what? We already knew one of those zeros was minus a half. Right? That was one piece of information they gave us at the very beginning. Let me take you back. One of the two zeros is at minus a half. So that evidently means the other zero is the x equals minus 2. Do we have to divide by minus 1? No, already. If you are comfortable factoring this thing with a negative lead coefficient, be my guest. Personally, I don't like working with a negative lead coefficient when I'm doing a quadratic. So no, you don't. Right? There is nothing in math that says you got to do it this way. I keep repeating that. You have an open highway in front of you, and you can choose a route that gets you to the final destination. We all have to just make sure we end up at the same place. That's what's most important. Okay, so let me come down now and have a quick look at what was already in place. We have a vertical asymptote at minus 3, and we have an OA at 2x minus 1. Let's see what that looks like. Right? So 2x minus 1 looks like this. That's one asymptote there. And the other asymptote, x equals minus 3, is right there. And all I need to do now is put in the points that I know are there, and then I can come up with a reasonable sketch of this graph. So I know there are two zeros at minus 2. Not minus 2, was it again? Hold on 1 second. Yeah, at minus 2 and minus a half. Those are my two zeros. So I can put those in on the graph. Minus 2, let me put a different color. 1 0 is right there. And the other 0 is at minus a half, so somewhere around here. And I know, and by the way, do I have a y-intercept? Well, we don't actually have one spelled out, but we can figure this out, right? We can figure this out. We can put 5 into the function we had. Here's the function we had right here. If I put 0 into this for x, that'll give me what my y is. So 2 times 0, that would give us, so this for the y-intercept here is what I'm working out. So 2 times 0 is going to give me minus 1 plus 5 over 3, I think. Yeah, minus 1 plus 5 over 3. I think that's about right. So that looks like positive 2/3, what it sounds like to me. I mean, you can double check that for me just to make sure I'm doing the right thing here. 2 times 0, 5, 0. Yeah, I think that's 2/3. But you can double check that. So 2/3 should be somewhere around here. So I think I can put this graph in right now, right? I have a pretty good idea what this graph looks like. It should look something like this, coming through here, coming up through here. Then there's another piece that would be diagonally somewhere down here. That's just a sketch. That's all that is, just a sketch, just to get an idea of what that looks like. And at some point, you need to be able to do sketches like this, right? Where's my OA? Where's my VA? Where's my HA? Put them in and go from there. There is my sketch. There are my answers. There is my function. Everything laid out very nicely for you. Okay, I'm going to move along, folks. Unless there are any questions, you're welcome to stop me at any time. Like, really just ask me about if we have to divide by minus 1. Welcome that input. Welcome that, those questions. But if I don't hear any questions, I'm going to move along. Right? Room check-in time. Isaac, Harish, Janaya. Let me hear from all three of you. Isaac, Harish, Janaya. Just check in for me, please. Right? And Isaac, where's Isaac? Isaac, where are you? Okay, great. All right, so everybody followed what we just did. That all made sense, yes? Just want to make sure everybody's okay with that because I'm going to move on now. All right, next question. Cost of an appliance. Cost of an appliance. You buy something for $600 and the annual hydro cost is $115. So the annual cost in dollars, where N is in number of years, is given by this. The initial cost of the $600 plus the yearly cost of $115 times N, which is the number of years, divided by the total number of years. That equation actually makes sense for an annual cost. You're really saying, take my starting price, put the price that I'm paying per year for electricity, and divide that by the number of years that I've had that particular product. It is, what is this, fridge? Well, it doesn't know what it is, just sells appliance. Sketch a graph of the function. Oh, okay. As n gets very large, etc. Okay, so there's some other stuff here. We need to, and this is what I'm trying to get you to understand. You need to be able to take information that's given in a function, like a rational function, and decide what it looks like. One of the things on this is that there is a domain restriction, which is what? What's the restriction on the domain here? Can anybody tell me what the domain of this function is? I need to know what the domain is. Anybody? Come on, folks. Help me out. N is greater than 0, all real numbers but 0, Harish says. Okay, so I'm looking at Noah's answer. I'm looking at Harish's answer. I'd like to hear from other people before I make a declaration. So what do other people think? I'm not making any comments on the answers. I want to know what other people think. The answers are close, but not quite the same. One person says greater than 0. One person says all real numbers but 0. Where's the rest of the class? I need to hear from the rest of the class. Jeremiah says n is greater than 0. Apparently Noah and Harish. I agree with, okay, Harish is changing too. Isaac is, and Chiabon is checking in. Agree with Noah. Okay, good. So n has to be positive. N has to be greater than 0. Absolutely. And that's because we're dealing with a number of years. First of all, n cannot be 0, because if it was 0, this would be undefined. And secondly, we're talking years, so we don't have negative years, right? Yeah, we just don't. Not yet. Well, maybe at some point they will, but right now they don't. You can't have negative years. Sketch a graph of the function. Well, what do we know about this function? Before we try to draw anything, what do we know about this function? Do we know about, let's talk about HA, let's talk about VA, let's talk about OA, let's talk about all of those things, right? So let me start off with, is there an OA on this function? Does this function have an OA? Right? Is there an oblique asymptote on this function? Harish says nope. Is Harish right that this doesn't have an oblique asymptote? Right? Because we talked about oblique asymptotes a few minutes ago. Could this have an oblique? I don't think so either. Chris says no. Abel says no. Jeremiah is agreeing with everybody else. I need a reason though. I'm not sure that I accept that. Right? I'm not gonna declare yes or no on that. Jeremiah, go ahead. Mm-hmm. 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 Hmm. Interesting. Okay, Noah is saying degrees are the same, so if you divide them, you won't get the equation of a line. Interesting. What do we say happens when you have the degree of the numerator and denominator being the same? What kind of asymptote do we have? What kind of asymptote do we have? Because we do have some asymptotes here. Just so you know, we do. We have two kinds. I want to know what the two kinds are. We've already eliminated that there's no OA here. All right, so no OA. What else? HA and VA, Harish says. I agree with both of those two things. So let's start off with the VA. The VA, Noah is right. The VA of this line, let me go back to black here. The VA is let's just say n equals 0, to just be consistent with the letters, the variables that we're using here. All right, so n equals 0. All right, so I'm hearing that there's an HA as well. And what would that HA be? Okay, so y equals 115. I'm going to say C, just to be consistent again, is equal to 115. Right? When you divide the lead coefficients of the top and the bottom, you absolutely get 115. Okay. X and Y intercepts, because that's going to help us to figure out what this looks like. Okay, I'm contradicting myself. n-intercepts or c-intercepts. All right, you commonly know them as x and y-intercepts. So let me just stick with that then. Is there an x-intercept? Is there a y-intercept? Let me start with that. X meaning the n-axis, right? The flat axis, the horizontal axis. Does it have an n-intercept? Anybody? N-intercept. Come on, folks. I need to know, does it or does it not? Does it cross the n-axis at any point? Excuse me. Where do we look for that? Where do we look for an x-intercept? Let me put it that way then. How do we find an x-intercept? The numerator, okay? Set that numerator equal to 0. What does that give you? Go ahead, Jeremy. Mm-hmm. Okay, we just lost you there, Jeremy. Mm-hmm. Mm-hmm. It is negative. Mm-hmm. Okay, good. Yeah, it goes on forever. All right, so it's a non-terminating decimal. All right, so 5 point, what is negative? And I know we said that the domain is that n has to be greater than 0, but it might help us to draw the graph if we knew where the n-intercept was, because we need to have an idea what this graph looks like. And we're not going to use Desmos. We're not going to cheat and use one of these electronic ways of getting it. We're trying to do this with just what we know about these functions. Okay, so there is an n-intercept, but it's negative. Yeah, we get that. What about the vertical axis? Where does it cross the vertical axis, the c-axis? Where does that happen? Anybody know where it crosses the vertical axis? Help me out here, folks. Where does it cross the vertical axis? At 0, 0, I'm hearing. Harish. Okay, what do other people think about that? It crosses at 0, 0. Do you all agree with that? So you're saying at the origin, in other words, Harish. I need to know what other people think. Does that answer sound about right to you? Are you going to jump on the Harish train, or you're not sure? Where's that vertical axis? It's actually c-axis, by the way, in this case. Where's that point of intersection? Where does it cross through? The c-intercept is what I'm asking. Yes, that's what I'm asking for, Noah. Where does it cross the c-axis? Which is the y-axis. Just let's put it in those terms so it's more relatable. Where is it crossing through the y-axis, or wouldn't it be undefined, you're saying? That's interesting. I don't know. I'm asking you though. Harish says it's at 0, 0, and you don't seem to be so sure. Come on, folks, think it through. Harish says, is it a hole then? I think there is no intercept. Okay, Harish is saying 0, 0. It doesn't cross the y-axis, Emily says. That's a whole bunch of different answers. Okay. So unfortunately, you can't all be right, and I'm not sure that anybody is right yet. I'm not going to say that. I'd like to hear other people, right? All right. And thanks, Emily. Thanks, Harish. Thanks, Noah. I really respect and appreciate all the input that you're putting in as we go along. All right. So the Noahs and the Harishes and the Jeremiahs and the people like those, they're doing their part. All right, Liz, how do you feel about this? What's your take on this? Right? Let me hear what you think. Where is that intercept? Okay. Are any of these people right, or they're all out to lunch? They don't know what they're talking about. All right. What do you think, Liz? What's your take on it? Give me your best guess as to where this crosses the vertical axis, the y-axis. Let's call it the y-axis just to make it easier. Liz, are you there with us? Okay, 0, 0. Okay, we got another 0, 0 in there. Okay. The v is x equals 0. Okay, we established that. So it can't cross. Okay. Okay, so I don't think it crosses at all. Yeah, and look, if you look at what Noah said, one of the things I've said to you, right, and I've said this a few times, is that yes, you can cross through a horizontal asymptote. We have seen graphs that cross through horizontal asymptote, but you never see a graph crossing a vertical asymptote. this graph's vertical asymptote is the n equals 0 line, the y-axis basically, the n equals 0 line. It's not going to cross that line, right? It's never going to cross that line. So it means that there is no c-intercept, right? There is no c-intercept. So that should help us to try to put this together. So I'm going to do a rough diagram first of this, and then we're going to do a little bit more refined diagram after that, okay? So I'm going to put in my x and y axis. I'm going to put in my HA, which we agreed was C equals 150, and we'll put that in with a dotted line. I always use dotted lines for that, as you well know. And I'll use a blue for that. So it should look something like this. And I'm going to also put in the VA as this other dotted line here, which coincides with what we call the y-axis. In this case, it's actually the c-axis. And then we're going to put in what we're calling the x-intercept. It's really the n-intercept, and it's somewhere over here as a negative. Negative, what was it again? 5.2, somewhere down here, negative 5.2. That tells me that this graph, we don't have any other intercepts to play with, that this graph probably looks something like this on this side. I know we said that n can't be less than 0, but I just want to have an idea what it looks like. Then it's going to look like this, which is diagonally across from it, right? So that's just our rough sketch of this graph. So I'm going to do a little bit more refined version of this graph right now. I'm going to leave out, I'm going to put a Cartesian plane in. Right, I'm going to change this a bit here. Just give me a second to do that. Let me do this first. Oh, I need to right click on here, change the properties. And on my x-axis, I'm going to go further. I'm going to take it back down to, oh, we're going the wrong direction there. Take it down to 0. And then, let's go -1 actually. And then on my other side, I'm going to go all the way up to about maybe 10. But on the other axis, I need to go up at least up to 115 because I know it goes, that's where my horizontal asymptote is. So I'm going to start at, I don't really need much of this axis. So we'll go -1. And then we're going to go all the way up to about 200. All right, because we need the graph to go quite a bit on that axis. Oh, sorry. In the right box here. 200, right? And then I'm going to go in jumps of about maybe 10. All right, let's see what that looks like now. Okay, so there is the grid that I'm going to be using. Hopefully everybody can see that. I'm going to put in my horizontal asymptote on there at 115. We talked about that before. 115 will be in between 110 and 120. So I'm going to put that horizontal line in right now. All right, I'm going to put that in a different color, maybe blue. I've been using blue for that. So I'm going to say it looks something like that. And we said that our line, right? If you look at my rough sketch over here, right? I can also put in the VA, by the way. I can put that in before I change this over. Oh, sorry. Here's my VA coming in right now. All right, so this over here is my n-axis with the number of years. This is my cost axis on the other side. And my graph should look something like this. I'll put it in blue, consistent with what we're doing here. Actually, let's use blue. Here's my graph. Looks something like this. So there is a floor to this graph. It is coming down from the day that you buy this appliance and trending down towards that horizontal asymptote, right? That's what we're saying. Now, I didn't plan very well because I need to move this thing down, and everything is, I wonder if I can make everything move down with it. Let's see if I can do that. Maybe I can. And oh, actually, this comes down with it as well. I don't want that to move. Let's see now. Let's move this out of the way a bit here. Move it over to the side. Then let's see if we can make this part move down. All right, and then we can move the other part back. Okay, so it's at 11:14. I know somebody's going to start complaining soon about wanting a break. All right, let's just do this before we get to the break. Sketch a function, which we've done. As n gets very large, what happens to the cost? Let's answer that question first. What's the end behavior of this function? As I move towards n becoming infinitely bigger after 10 years, 20 years, 15 years, what's happening to the cost? Is there some value that the cost is moving towards? What do you think, folks? It is moving towards 115. That's exactly right. Never gets there, right? Because what's happening is that the initial cost that you bought the fridge for, the $600, is beginning to disappear. And really all you're left with is just the annual cost of $115. Okay, that said, it's 11:15. Folks, we're officially on break for the next 5 minutes. I'm going to shut my microphone off, go do all the things that I encourage you to do during the break, and we'll come back in 5 minutes. Okay, so let's continue with the question. Everybody else is back. So as n gets very large, what happens to C? And the answer to that question is that C is approaching, the cost is approaching $115, right? What's happening is that the $600 that you paid for the fridge is practically disappearing, right? What's happening is that the only cost that you really have after a while is just the cost per year. Determine using algebra the number of years needed to reduce the cost to below 200. Okay. So here's our graph, but I'm not going to focus so much on the graph. I'm going to focus on the algebra right now. Can we set up an inequality, because it sounds like it's an inequality, that can help us to solve this? Determine using algebra the number of years needed to reduce the annual cost to below 200. Jerry, you want to tell us what? Okay, so it has to be less than, because you said you want that cost to be below 200. So we'll go ahead and write that and we will solve that inequality. So here we go. Grabbing my stylus here. So 600, what color am I? Let's go back to black. 600 plus 115n over n is less than 200. How do we solve this? Let me get some ideas on how to solve this. What do I do to solve this, folks? Help me out. All right, we need to solve for n. What do I do to solve for n? Bring the 200 over. So you're saying minus 200 from the two sides, then put it over 1, Noah says. Bring 200 over left and then add a negative. Okay, I hear all of that. Here's my question. Can I just cross multiply? Would that be okay for me to just cross multiply? I know what you're saying. You know, we always say we shouldn't cross multiply. I'm saying, is it okay for us to do it now? Right? Kayla says yes. Oh, wait, yeah, because we say, okay, great. Jeremy had a question. Yeah. You have to remember that if there's a restriction on the domain which causes the denominator, the thing that you want to cross multiply by, to be always positive or always, if there's always negative, then you could also just switch the direction of the equality. It's always going to be the same sign, then you don't have to worry about it. Okay, so in this case, we don't have to worry about it. So I'm going to go ahead and say, okay, so 600 plus 115n is less than 200n. Absolutely. And then we can take that 115 from the two sides. So 600 is less than 200n minus 115n, which means that 600 is less than, this looks like 85n. And just remember that you can always switch around the two sides of an inequality. So I can write this on the other way. I could say 85n, 85. Okay, let me just undo that. 85n, the only thing is I have to switch, if I'm switching the inequality around, I have to switch around the direction of the inequality, is greater than 600. That must make sense, right? It has to point towards the same thing. So that means that n must be greater than, but not equal to, by the way, 600 over 85, whatever that is, right? And you all have calculators. Please help me out. My calculator isn't close by. What does this mean that n has to be greater than? Anybody quickly? 600 over 85. What is that approximately equal to? What is that? What is that? Help me out. About 7.1. All right. So as long as n is greater than 7.1 years, then the cost will be under $200 per year. This, remember, let me just remind you what this cost was. This was the cost in, is given by the annual cost. So this is the cost per year, right? This function here is the cost per year. So it's really a rate. This is what it's costing you per year for the fridge. So it's taking the initial cost plus the cost per year, dividing by the number of years, and et cetera, et cetera. Okay, I'm going to move along. Thank you very much for your help with that one. I'm not remember how many more questions I have, but I'm going to try to get through all of them, and then we're going to start our trig unit after that. Unless anybody has anything else from the problem set. So let's just see which ones I have first. And if there's anything else you want to add to that, then we're more than welcome to do it. Okay, next question. The cost in thousands of dollars of running a car wash can be modeled by, and they give you a function. 3 over 45 minus n, where n is the average daily number of vehicles that use the car wash. Sketch the function, determine an appropriate domain, and explain how you determine it. Calculate the rate of change at n equals 25. Okay. I think the important thing here is to sketch the function. Now, again, we're going to try to do some of the things that we did on the last one. Come up with some things that might help us to sketch it, like the HA and the VA, and then any intercepts, and see if any of those things can help us out. Come up with a domain as well, right? Because that will help us to figure out what it might look like. Jeremy had something you wanted to add to this. I see HA here. Oh, okay. So you want to tell us that the HA is that y equals 0. And you're right. And that's because the numerator has a lower degree than the denominator. And that tells us that the HA is the x-axis, the y equals 0 line. So let's write that down. HA, and I'm going to be consistent here, right? Remember that we're talking about C and N. I mean, not that that's a big deal. I'm going to take any marks off for that. But it would be the N equals 0 line, which is the same thing as the, the C equals 0 line. All right, that's my HA. That's my horizontal line. All right, so I know it's easier for you to think of it in terms of like X and Y, but I'm just going to use what the variables are in this case. So C equals 0. And I see that Jeremiah also is suggesting a VA. And that VA would be my N equals 45 line. Okay? Yes, Jeremy, go ahead. Sure. Let's, because we're going to need those as well. So let's say our N intercepts, first of all. I know that makes it a little bit more challenging for you, but let me hear what you got for that. N intercept and also my C intercept. So none. Okay. Good. Good. So none for the N, and for the C intercept is 1 over 15. And that's, of course, just plugging in 0 for N and getting that number. Okay, so let's see if we can kind of roughly figure out what this one looks like. This is all about sketching functions and coming up with an idea of what this looks like on a graph. So let me, oh, by the way, the domain of the function, let me talk about domain of the function before I go any further. What is the domain of this function? Not just Jeremiah, by the way. I need to hear from some other people here. What is the domain of this function? What would make sense for the domain of this function? Come on, folks. I need some other input on this. What would make sense? All real numbers less than 45. That's interesting. So you're saying n must be just less than 45? That's it? Because I would agree with you to an extent, but I need a little bit more than that. What else should we say about n apart from it being less than 45? I agree with less than 45, but can somebody refine what Harish just said a little bit? Come on, folks, think about that domain. What values of n? N represents the number of cars that I am washing. Is it per day? I was daily, yes, the number of cars that I'm washing per day. So must it less than or equal to 45? Okay. Well, if it was 45, would we have a problem though? Okay, put your mic on mute for me, please, Jeremy. Okay, right. Wouldn't 45 give us a problem if you think about it? You said less than or equal to 45 and Joel. If n was 45, wouldn't that mean that we're dividing by zero? So I'm going to say that maybe we need to refine that. Maybe not just or equal to, because equal to would give us zero. But here's another thing we need to think about. What does n represent? Can n be anything less than 45? Hmm? Can n represent any number? Okay, so it has to be, that's a very good point. It has to be whole number. So integers, right? So integers like 1, 2, 3, 4, 5, 6, 7, 8, 9. But we don't have a piece of a car. You know, it can't be like 6.5 cars or something like that. But what else? Can n be negative? Is it possible for n to be negative? What do you think, folks? Can n be negative? So all whole numbers, yeah, I get that, but can n be negative? What does n represent? And it's the average daily number of vehicles that use the car wash. Can n be negative? I'm gonna have to say no to that. So it sounds like my domain of this function, domain, is anything from 0 to 45 with round brackets on either end. Okay? And thank you, Keontae. Round brackets because we're saying it cannot be 0 and it cannot be 45, right? So I know you gave me the c-intercept as being 1 over 15, and I agree with that. If in theory we were to make 0 for n, but we know that in reality, because of what we're dealing with here, where n is the number of cars, we can't have. Actually, you know what? Let me take that back. Let me take that back because I'm assuming that I'm gonna reverse course on that. I'm gonna reverse course on that. It may be possible for you to have a cost if n is 0, right? Because that would mean that you still have some cost for keeping the lights on in your. I'm just thinking in terms of a realistic situation here. If you had 0 cars in your car wash, which is perfectly possible, then it just means that your cost is now 1 over $15. Then let's put it that way. And this is in thousands of dollars, I think. Yeah. So I'm going to take that back. I'm going to take off the round bracket on the 0. Now that I think about it some more. And I'm going to put a square bracket instead. Right? Because I'm thinking whole numbers, yes, Keontae, you're right. You could have an initial cost, right? You open your car wash, nobody comes to your car wash. That's just your bad. Nobody wants to use your service. That's too bad, right? But you still have costs because you got to turn the lights on and you probably pay the rent and all that kind of stuff. So unfortunately, there are some costs there still, right? And you can go all the way up to 45, but not exactly 45 because there's some capacity. And 45 will give you 0. So anywhere from 0 up to 44, I guess, would be one way to do it. And in fact, let's do it this way. Let's say 0 to 44 because we can't really have 44.5 cars. I'm going to change again. Okay, I'm going to change this one more time. I'm going to say it goes up to 44. And let's include 44 as one of the answers again. Okay, so little changes of direction. As the more I think about it, the more it kind of evolves a bit. And I'm going to say anything from 0 to 44, all of those numbers are acceptable. None of those gives us something that's undefined, so that works. Now let's try to draw this now, sketch the function. We have a C value, sorry, we have a HA, we have a VA, we have intercepts that can help us out. I mean, even though we're saying that well, we are saying that C can be zero, that N can be zero. We've changed our course on that. So we do have an intercept right there. So let's try to put this together on some kind of a graph, a rough sketch right now. Right? I'm going to put in my vertical asymptote at N equals 45 as a dotted line again. We'll refine this later on. Right, so let's see now. We'll make this, I usually use blue, so we'll use blue. So we'll say it looks something like that, and that's at 45. And we also said that there was the C equals 0 line. So the other asymptote is actually right here on the horizontal axis. Right? So far, so good. You have, yeah, okay. All right, so there we have the two asymptotes, and I'm trying to figure out, now remember, if it's something like this, then it means it's going to be diagonally across from each other. The intercept will help us out. We have one intercept that we said is up here at 1 over 15. So 1 over 15 would probably be somewhere like about maybe here. Maybe, I mean, I'm just sort of using approximates here now. Right? So I'm thinking, all right, so we have an asymptote here, an asymptote here, and we have an intercept right here. You can always come up with a graph for functions like these if you put your intercepts in and your asymptotes in, because you know that they're going to be diagonally across from each other in cases like these, in simpler graphs like these. Because this is really the reciprocal of a linear function right there, reciprocal of a linear function. The top is a constant, and the bottom is a linear function. And I have my intercept right here, positive 1 over 15. I have to be asymptotic to this and asymptotic to this. So I'm thinking, you know what? This is going to look something like this. And then, of course, there's another piece on the other side over here. No, that piece on the other side, we're going to say we're not going to accept that in our official drawing because we already said that C had to be between 0 and 44. And by the way, this asymptote here is at 45. Right, this is my, I'm going to put 45 down here. So I'm going to, in fact, I'm not even going to bother to put in the Cartesian grid. I'm just going to label this the way it is right now. I'm going to take this part out because I really don't need this part right here because X only goes up to 44. And I'm going to put that, this is my number of cars axis. So cars, number of cars, and this axis here is my cost. All right, my average daily, the cost in thousands of dollars. So it looks to me as if your costs start off down here. We don't have anything on the negative side, by the way, of the number of cars. It just seems to rise and is trending towards infinity the more cars you wash, is basically what we're saying, right? So your cost is rising quite dramatically as you try to wash more and more cars, right? So we sketch a function. What's an appropriate domain? We talked about that. The rate of change when n is equal to 25. Does anybody remember how we do a rate of change? If I ask for the rate of change when n is equal to 25, what am I asking you to do to get that rate of change? Come on, folks, let's get back to it. Find the slope. It's an IROC. It's absolutely an IROC. So unfortunately, I know IROC is pretty tedious to do, but we're going to do that right now. All right. So I'm going to go ahead. And by the way, just remember that they said that the C is in thousands of dollars. All right. That's just reminding you about that. And the N is the number of cars. So what I'm going to do is I'm going to take my function. I'll remind you what the function is. C is equal to 3 over 45 minus N. And I'm going to find the C of 25. And I'm going to find the C of 25.01. And I need your help because you're the guys with the calculator. It's an IROC calculation. And then we're going to go ahead and we're going to find that stuff. We're going to express it with the correct units and answer the question. $8 per watt. What is it? $8. Yeah, thanks. $8 per watt. Thank you, Kianti. Thank you all of you for saving me from myself. $8 per watt. Everything is per something. What is this $8? This is in money. This is a cost. Is this $8 per car? Correct. So when you're doing the 25th car, right, your costs are actually increasing at the rate of $25 per car. That's what's going on. Your costs are increasing all the way along. As you do more cars, your costs are increasing. On a 25th car, your costs are increasing at the rate of $8 per car. Just that's all we're saying. Okay, let's move along. That was bad, and not your fault, my fault. All right, we'll think we make this one the last one for today. Let's see if that's the last. Oh, maybe we'll try two more. Okay, all right. What? Two more to go. Two more to go. Thank you very much for all that input, by the way. Carison, Noah, Keontae, Harish, all of you stepped up big time. Aliza as well. Everybody in that group that really came up. Okay. All right. So we'll do two more, and then we're going to start our trig after that. All right. We'll take a 2-minute break as I set up for trig, but let's just get these other two done. And then again, if there are any other questions that you have for the problem set, I'm expecting you to come see me in that 3 to 3:30 period. So on Monday, I'll give you the test part of this, and then the problem set or the assignment part will be on Tuesday. Just remind you that that's the plan, because you have single period classes next week. All right, let's move on. Electrical circuit, the current is measured in amperes, is given by this formula, and they give you that, where T is the time in seconds. Describe what happens to the circuit as T approaches 15 seconds. And determine any discontinuities in the graph. This shouldn't take us too long to do. If we can graph this, if we can have an idea of what this looks like on a graph, we can easily answer what happens to the circuit as T approaches 15 seconds. So let's analyze. HA, VA. All right. Now, Jeremy is the one who normally steps up. I'd like to see somebody else stepping up this time. Give me an HA, give me a VA. All right. So X equals 15. Okay, again, it's actually T equals 15, but we'll go along with that. T equals 15. Okay. Okay, actually that's not the HA. That would be the VA. T equals 15. All right. So, and Nicholas is saying that the TA is equal to -1. So the L is equal to -1. Right? That's my vertical line. Okay. All right. It is L, in fact. Yes, Travis. Yes, absolutely. No, that's good. That's good. All right. So we now have a good starting point. How about intercepts? We know we need the intercepts as well to guide us when we're putting this together. Now, again, Jeremiah is usually the one who steps up with this. Give me I'd like to hear some other people. So we can't have Jeremiah carrying the load for the whole class. Let me get some other people in on this. T equals -2 is what you're saying is the T-intercept. Good. T equals -2 for the T-intercept. This is the T-intercept here, by the way. And is there an L-intercept? Is there also an L-intercept? 2/50. Okay, good. All right. And I know Jeremy probably had his answers ready to go. Okay. Now, let me see if we can put this somehow together, right? Let me put that VA in. Remember, this is our T-axis here, and this is our L-axis over here. So I'm thinking that T equals 15 will be a line, like put a dotted line in for my asymptotes. So let's put one in around here. And -1 for the other asymptote on this one should be somewhere about here. So I'm going to label this one here -1 and label this one here +15. The intercept on the T line is at -2. So that's somewhere over here. Intercept on the other function is at 2/15. So that's somewhere up here. So it's pretty clear what this graph is going to look like. It should be pretty clear what it looks like. It should come from over here, right? It should be coming down through here, and then it's trending up towards this asymptote on the other side. Now, it is true that the domain of this function should be anything. The t has to be greater than 0. That should be hopefully obvious. And excuse me. And it's looking like the t cannot be more than 15 either, right? Because it's more than 15, it's going to become negative. Time's going to become negative. It's going to be somewhere over here. So there's another piece that's on the other side over here, but it doesn't seem as if it's going to be relevant to our situation. So I'm going to say that t has to be somewhere between 0 and less than 15. Okay, anything more than 15 makes this become negative, so we don't really want to have that to deal with. So now let's ask the question, right? Jeremy, you can chip in on this one as well. Describe what happens to the circuit as t approaches 15 seconds. Right? What happens to the circuit? Okay, Jeremy, please go ahead. Okay, does everybody see that? Does that make sense to everybody? Right? Let me do a quick check-in here, right? I'm not asking you to give me an answer. I just want to know if you're agreeing. Omar and Shiabon, are you both agreeing with that? Let me check in with Omar first. Omar, are you there? Thanks for your speed. Good. And Shiabon, where's Shiabon? Shiabon, where are you? I'm looking for Shiabon. Okay, great. And does that make sense to both of you? So Omar and Shiabon did what Jeremy just say? Does that make sense to both of you, Shiabon and also Omar? Okay, great. So it's going to increase infinitely as you get closer and closer to that 15 seconds. Yeah, 15-second mark. Any discontinuities in the graph? Well, the discontinuity is that t is discontinuous at what is it, t equals 15. Let's move on. Right, I really would like to start our tricks off today, so I have one more question I thought we could do, which is this one here, and then we're going to stop in terms of the rational function stuff. Okay, all right. As blood moves through the heart, your heart, my heart, anybody's heart, through the major arteries out to the capillaries and back through the veins, stuff you learn in biology, the systolic pressure continuously drops. The pressure given by the function, and they give you a function, 25x squared plus 125 over x squared plus 1, where P is measured in millimeters of mercury and X is measured in seconds. Using the steps from the class, sketch a graph of the function, use an appropriate domain. What is an appropriate domain and range? Determine the instantaneous rate of change as blood pressure goes from x equals 5 seconds and at 10 seconds, explained by the difference between part A. I'm going to leave out C and D, right? What I'm more interested in right now is to see if we could sketch this. If we could come up with a reasonable sketch of this function. That's what I'd like us to focus on. Okay? And I'm going to ask all of the same questions that we normally ask. And I know Jeremiah is one that normally answers, but I want to hear from other people on this as well. I'm going to be asking for HA, VA, or OA, because it could be an OA. I'm going to ask for x-intercepts and y-intercepts. All right? Now, I haven't brought the wheel out yet, but I'd love to hear. And you know what? There are even some people who have also been very forthright. Nicholas is one of them. Harish is one of them. Noah is one of them. Right? I really appreciate those people, but I haven't heard from a whole bunch of other people either. Keontae, yes, those are people who are great at chipping in and helping us out. But there are a whole bunch of people who haven't done that. And you're part of the class, and I need to hear from you as well. So if it means I have to call on one of you, I'm going to do that. Right? So the rest of you that I just commended for your input, Noah is one of them, by the way, who I'm also commending. I'm going to ask you to hold your fire for a bit. All right? And I'm going to be, in fact, yeah, I'm just going to call out one of those people who hasn't really contributed as much as I'd like them to. So I'm going to be asking for the following things, and then we can try to draw the graph. Where's my HA? Where's my VA? If there's an OA, let's just dismiss this. There's no OA, okay? And I'll just say why there's no OA. There's no OA because that comes when the numerator has a higher degree than the denominator. That's not the case here. So there's no OA. Let's just dismiss that. And I'm going to be asking for an x-intercept. And I'm going to be asking for, in this case, it's a p-intercept, just to be consistent with the variables that are being used here. All right, so everybody else, hold your fire for me, please. All the usual sort of participants who are always there for us, always chipping in, always ready to work with us. Sharissa, let me ask you, please. Can you give me an HA for this function? Let's just make sure you're there first. Sharissa, are you there with us? Where's Sharissa? Where is Sharissa? Looking for Sharissa. Sharissa, you're in the class, right? Okay. All right. Can I give you the can I give you the VA instead? No, let's walk you through the HA. Let's walk you through the HA. So work with me now. You're listening carefully. I'll get to the VA in a little while. Listen carefully. I'm going to give you a clue as to how to get that HA. All right. The HA has to do with the degree of the numerator and denominator. It's one of two things. If the HA, sorry, if the denominator and the numerator and denominator have the same degree, the HA will be the ratio of the lead coefficients. If the numerator is a lower degree and the denominator is just going to be the x-axis. So let's do this first, Sharissa. Tell me whether the degrees are the same or whether the top has a lower degree than the denominator. Or the numerator is lower than it's one of those two options. Let's start with that first. Which of those two is it? Are they equal or is one it's the same? Thank you. Okay. When they are the same, we look at the lead coefficients of both of them. And we take the ratio of the lead coefficients. So the lead coefficient of the numerator divided by the lead coefficient of the denominator. So let's see if you can help me out with that. Okay, so it's 25. So it's not just 25, you're right. It is that P equals 25. I know we don't want to say Y equals, but because we're dealing with a P function here, we're going to say P equals 25. That wasn't so hard, Sharissa. Right, you got that. You see how you got that? You're, with a little bit of prompting from me. Make sense? Does that make sense to you, what we just did? Okay, right. And I'd love to hear from you more, by the way, just so you know. Okay, so I'm going to be asking for the VA now, right? And I'm going to go to RIDI on that one. RIDI? Or no, let me go to, yeah, RIDI. Let me go to RIDI. RIDI, are you there? Where is RIDI at? Looking for RIDI. Okay, RIDI. Give me the VA now, please. What is the VA on this one? And if you need some clues, quite happy to help you out with that. If you want a little push start is what I usually use. That's the expression I normally use. Is it -1? Is that what you're thinking? It's -1? Or is it positive? Are you just saying, is it 1? I'm not sure if you're saying. So 1 or -1, which one? So you're saying -1. Okay. Let's do this. And I know other people have their ideas as to what this is, but I just want you to hold your fire for a minute. Where does the vertical asymptote come from, really? Where do you look to find the vertical asymptote? Where do you look for that? Perfect. Well done. Now, to get the vertical asymptote, listen carefully now. It's what value of x makes the denominator, as you said it, the denominator, what value of x makes the denominator become 0. If I put -1 into that, I'm not going to get 0. Because -1 squared is just 1, plus 1 is 2. So -1 doesn't work. Can you give me another answer for the vertical asymptote? Is there some other number that I can put into that denominator which will give me 0? Think about that. And I'm not rushing you. I want you to think it through and give us an answer, please. What value of x can I put into that denominator which will give me 0? And I can give you another little hint if you're not sure. So let me know if you need that hint. Okay. So what I'm going to do here is I'm going to take that x squared plus 1. That's the denominator, right, RIDI? That is the denominator? Yes, RIDI? Okay. let's set it equal to 0 and try to solve it. Everybody else, you just have to be patient, right? We're all trying to make sure that we all end up at the same place. You just have to be patient. So let's set it equal to 0 because that's what we're trying to do. We're trying to make it into a 0, right? And let's try to solve this. What would your next step be in solving this, Really? Tell me the next step. If you had this question to do, what would you do next to solve for x? Because that's how we're going to get the value of x that makes this thing become 0. We're solving an equation now. X squared plus 1 equals 0. What's the next step? Take the 1 to the, okay, good. So tell me exactly what to write there. If I put the 1 on the other side, tell me exactly what my next line is going to say, if that's the case. I want to hear that from you. But I'm going to write down exactly what you say. So x squared is equal to 1 minus 0. Fix the right-hand side of that equation. It's not 1 minus 0. The 0 is already there. Shouldn't you be minusing 1 from that? Isn't that the way it works? Okay, so I'm going to write that down. So x squared is equal to 0 minus 1. Keep going. Because you can work out what 0 minus 1 is, right? Okay. So x squared is equal to minus 1. Okay, keep going. What's next? What do I do to solve for x at this point? You square it? I'd say it's opposite of that because right now it's squared already. Why would you say there's no VA? I'm not going to agree or disagree with you yet. I want to know why you're now saying there's no VA. Because you can't solve it. Thank you very much. Because your next step would be to say that x is equal to the square root of minus 1, which there is no real solution. I know that some of you are eager to get into imaginary numbers, but there is no real solution. And if there is no real solution, there is no VA. Okay? Thank you, really. And there are times I'm going to have to do that. So, folks, get ready. If I want to get everybody through this course, there are times we're going to have to slow things down and make sure that everybody's on the same page. Okay, so we've got the HA, we've got the VA. I'm going to be calling on another person again to give us the x-intercept and the p-intercept. Let's see. Rachel. Rachel, you there with us? Is Rachel there with us? Great, Rachel, give me the x-intercept, please. I can show you the equation again. What is the x-intercept? Can you tell me what the x-intercept is? 125. No. Remind me where to look for the x-intercept. Remind me where I go to get the x-intercept. Right? When I have a rational function, what part of the equation gives us the x-intercept? The numerator. So it's what makes the numerator equal to 0. Remember? So think of the steps that I just went through with Riddy a few minutes ago and see if you can tell me what that x-intercept might be in this case. Set the numerator equal to 0 and solve it. And tell me what you think the x-intercept might be when you do that. If you need some help, just let me know. If you need a push start, need a little hint, tell me, and we can work it through. Thank you, because you cannot make the numerator equal to 0. So none. I wonder what this thing looks like then if it has no x-intercept. All right, we're going to figure this out. How about the p-intercept? Thank you, by the way. Thanks both to Riddy and to Rachel. All right. Let me hear now from, let's see. Kale. Kale, are you there? Is Kale there? Where's Kale? Okay, perfect, Kale. How about the p-intercept? Can you help me with that? Where does this thing cross through the p-axis or the y-intercept? Just to make it easier for everybody. So Kale is, Joel, could you please hold on? I don't want any other answers except from Kale right now. All right. So Kale, I'm going to say that you're right to that. And let's see if we can draw this now. What does this look like? What does this thing look like? So we'll just draw a regular thing and we can refine it later on in terms of the domain. But for now, let's see what we can put on here. Actually, I'm going to need a little bit more room for this. A little bit more room for this. So let's come down here. And let's put in the stuff that we know. There is a horizontal lasso that p equals 25. So that's a horizontal line. I'll put that in. All right, so horizontal line. I usually go blue, no particular reason. We said there is no vertical asymptote. Okay, so I can't put any more asymptotes in. I said there is no x-intercept. Whoa, that's making it more challenging. But there's a p-intercept though, and it's at 125. Okay, so I'm gonna have to extend this a bit. Oh, geez, wrong thing there. Hold on, hang on. So I'm gonna have to extend this. It's not the line, it's this. So I'm gonna have to extend it. Oh. Okay, please don't tell me you're gonna crap out on me again today. Yesterday, my whole thing. All right. Pen. We want the pen. That's what we want. We just want the pen right now. We don't want a line. Okay, good. And we want the line to be black. All right. So, folks, all right, you know what? I'm just going to draw it in with the pen here. Okay, there's the black line right there. And 125 is somewhere up top here. 125. So I'm thinking, wow, it has to cross the vertical axis up here. It has to be asymptotic to this line down here. It doesn't have any x-intercepts. It doesn't cross this line down here. So what does this thing look like? Well, it looks something like this. Right? I don't think I did that justice, but hopefully people get the idea. It's coming up from that 125. It does have a negative side on it. If this was just strictly this function here, 25x squared plus 125 of that, then it would have a negative side on it. But for our purposes, because we're talking about x representing seconds, it really starts here at 0 and then goes down from there. So does this have a domain? Yeah, the domain of this function, how is going to work? Is this going to work for me? No, it's not going to work. It's not going to work. I'm going to close this board up in a second because it's misbehaving. Can anybody suggest what the domain of this function is? Let me go to the room on this. What is the domain of this function? Where does this function start on the x-axis? Where does it end theoretically? Right? Can anybody give me a domain for the function? And I'm throwing it out to anybody. I'm not asking anybody in particular now. So it's 0 to infinity. Yeah, I agree with that. From 0 to infinity. I'm going to write it with this. Like that. Okay? Thank you, Harish. So starts at 0. So when time is zero, and it can go on as high as you want to go, it does get closer and closer to the asymptote as you go along, the horizontal asymptote, which of course we said was 25. Okay. All right. I'm going to leave it there. All right. I'm going to leave it there. If anybody has any other questions, then by all means come see me and we can go over them individually.